question here is asking us to determine the magnitudes of the projected components of the force F, which is 300 newtons, acting along the x and y axis. So the first question here is asking us to determine the magnitudes of the projected components of this force. The projected component of this force, we can see that along the y-axis it's a straightforward, and we can find it through the cosine law. F cos 30 to find the one on the y-axis, because it's making a right angle triangle in here. What about the x-axis? The x-axis in here, it is shared between the z and x-axis itself. Therefore, we have this component in the middle between the x and the z axis. Let's call it f prime. Finding f prime first, and we will share it between the x and z axis. So finding f prime, so first thing, finding f prime. F prime in this case equal to, so this component which is making the right angle with this one here, which is 30 degrees, equal to f sine 30. And this component will be shared with the x axis and shared with the z axis, both components in there. So now starting finding the force vector F. Force vector F. The force vector F equal to, now the first step that we are going to do, we know that we have a component which is, let's take F itself out as a shade between all of them. Now for the x components, it's a negative, it's on the negative x-axis, that's a negative, and it's shared sine 30, so we put down here sine 30 first. And when we look at the diagram, this is the component here, and it is also sine 30. So to find this component, which is f sine 30, this component which is the x-axis, negative x-axis, therefore it is sine 30 degrees I plus, in this case, the y-axis, as we said, is going to be straightforward, which is f cos 30. F, we've taken it out in there, then we left with cos 30 degrees j plus, looking at the k component, the k component here, it is shared sine 30 with it, so let's put it down first, sine 30 degrees. Now the k component, which is this one here on the z-axis, and in this case is going to be f cos 30. We've taken the f out in there, then we are left with cos 30 degrees. Plug all of this into your calculator and you should get the force vector equal to, in this case, negative 75 I plus 259.8 j plus 129.9 k, and of course this one here, it's in Newton. Now we found the force vector F. Next step is to find the vector dot product. Vector dot product. Vector dot product in this case will equal, along the x component, F along the x component equal to, we know that it's F dot I, which is equal to the F, which is this force in here, negative 75 I plus 259.8 J plus 129.9 K, dot I. When we multiply this, we know that I will go, when we multiply both of them, then I multiplied by I, this will remain negative 75. Negative 75 multiplied by I, which is 1 in this case, plus it's a 0 component for this one in here, 259.8 multiplied by 0 plus 129.9 again multiplied by 0. So we are left with negative 75 Newton. It's a negative, that negative in here, this one, negative, indicating we are on the negative x-axis. Now, we found the components along the x-axis. We will do the same thing to find the components along the y-axis, which is equal to f dot j equal negative 75i plus 259.8 j plus 129.9 k, of course, dot j. Now we multiply, and remember that j will go only with j, so it's negative 75 here multiplied by 0 plus 259.8 times 1, unit vector it's 1, plus 129.9 k here multiplied by again 0, therefore we left with 259.8 Newton. Therefore this is the force components, or the projected components along the x and y axis. This is the first question here, asking us to determine the magnitudes of the projected components along x and y axis of the force, of this force in here. This is how to solve the problem. For the next question here, guys, I will do it in the next video, but for now we have to know this is the way you solve this problem. It's an easy and straightforward one. Once you find the transverse component or transverse angle, just find it and see transverse angle shared between which two components. Share it between the components that you found. In this case it was x and z, which is sine 30. Sine 30 is for both of them, but sine 30 it's a negative on the x component, positive on the z component. See you in the next video, guys, to continue the second part of the question.